What's up, guys? So I have here a LiDAR, like a really cheap. Uh, it's called an RP LiDAR, right? These I think are about like $400 ish. So I'm going to connect the USB of this LiDAR into my computer, and you can see it starts turning, right? And before, let me stop it for a bit. You can see here, this is where the laser is. So it has a laser that sends out a laser and another receiver over here. So it bounces off and comes back to it, right? And so it rotates, and that's how it gets the ranges. So one rotation is one of those scans, right? And in one rotation, if you look at question 6, what we're getting is we're getting 180 scans in one rotation, right? And then the 32nd, so after that it'll be the second rotation, third rotation, and so on. And we looked at the 32nd rotation, which has another 180 points, right? So let me switch this on again. Right, so it's rotating now and it's getting data. So what we're going to do is we're going to use ROS to access this data, right? And so there is a ROS package called RP LiDAR. I've given you guys the link. If I go there, right, here you can see you can get the GitHub repo of that ROS package. I'm going to place this down for a bit so I can do this. Can't I move? Okay, there we go. Alright, so we have the GitHub repo of the ROS package. What you would normally do is you would clone it. So this is how you would normally set up a ROS package that someone else has created, right? You would go to your Catkin workspace. That's where you build your ROS packages. Again, if you find it difficult to follow some of this, go through the tutorials, and I think Alan will also cover some of the basics of this, right? So you clone it, right? And then say Catkin build. Source your dash file, and then to launch the package, launch the ROS node, right? You have this file called a launch file that you need to run to launch the ROS node that will access the LiDAR data, right? So to do that, I will first have to start a ROSCO. Right? And then I say ROS launch RP LiDAR. What is that? Give me a sec. Okay, I seem to be having a bit of an issue trying to access this. Okay, since we are running out of time, what I'll do is I'll show this to you guys next week. So it's just me, I just have to launch this and show you guys the data that's coming out of it. but I seem to be running into a small error, so I'll probably have to debug that, and that might take some time, and it's already 3 o'clock. So the last question, it'll take me like 5 minutes. I'll show you guys next week. Actually, there's a ROS bag that I have provided, and that should also show you the data. So I'll quickly run that, and instead of showing you the sensor, I'll show you a recorded version, right? So in the files that I provided you guys, so you can follow along with me as well, because I provided a ROS bag. So lab 3 material question 7, right? So I start a ROS core, and what I can do is play that bag. So I say ROS bag play and give the name of the bag, and I'm going to play it in loop, right? And then I'm going to run rviz like before, and then we should be able to visualize the laser scan, right? So you can add a laser scan topic from here and pick scan, right? And I'm going to pick the laser frame, and here you can see the laser scan. It's coming, right? So this you can try yourselves at home. I've given you a bag, so the robot is moving, and you can see that the scan is also moving because the robot is rotating in the same place, right? So kind of like what we did with ICP today, what you can do is step by step from each scan to the other, you can look at, kind of match the scans and look at how the robot is moving based off of that, right? So that's one way of getting localization information for the robot, to figure out where the robot is relative to the space, how much it has moved, how much it has rotated, and things like that, right? Because if you think about it, the robot doesn't know, right? The robot doesn't know whether it rotated or not. So it needs all these other sensors to tell it that it has rotated. So one way of doing it is using laser scans and ICP. You can also take an IMU, kind of like what's in your phone, that figures out rotations and things like that. You can use encoders, right? That's basically wheel rotations. It counts the amount of wheel rotations to figure out how far it has gone. You can use cameras to do it, and there's so many other ways. But usually what you do is you take a bunch of these sensors and you fuse all that information to figure out how a robot is moving, right? Otherwise a robot doesn't know where it is or how it's moving or anything like that, right? So all the information a robot has ultimately is from its sensors. And we use all these algorithms like ICP and all that stuff. And then generally we would fuse data from multiple sensors to obtain that information, because usually sensors also are not perfect. They have a lot of noise, and there's estimation errors and things like that. So we would look at information coming from different sources to kind of figure out and build a picture of how the robot is moving, right? So you can try this out. Just play the ROS bag, run it on rviz, and next week I'll set this up and show you guys the raw data coming from LiDAR, right? So it'll look exactly like what you're seeing now, right? So what I'm showing you now is a pre-recorded ROS bag. All right, guys, so that's the end of today's class. Any questions? Alan will want to talk to you guys now, so just don't leave the class just yet. Yeah, any questions? All good?
Marlene,
yeah.
I can't screen share, I think, because you haven't added me as a co-host. So if you don't mind doing that.
Okay, sure. Give me a second.
Yeah.
I think if I stop sharing, you should.
There's a change that's been put in place.
Okay, can you try now? You should be able to now.
Oh yes, I can. Good.
Yeah.
All right, awesome. So I'm here now for questions for the quiz, and I Before I open up to questions, if it's okay,